This lecture is on the middle ear, also known as the tympanic cavity. So, the middle ear then starts at the eardrum. And the eardrum, as you recall then, is a membrane covering the end of the external auditory canal. We discussed that in the last lecture. And the eardrum moves in and out in response to sound waves. So let's just start this out here. So here, then, let's have a little bit of the external auditory canal. Here it is, the external auditory canal. And here, then, we have the eardrum. So then, on the inside, or I'll say the inner side, on the inner side of the eardrum, a tiny bone is attached. And this is called the malleus. Which translates to hammer. So what I'm going to do here is that I'm going to make this highly diagrammatic. I'm not going to try and draw a tiny hammer, but I am going to indicate a bone here. So here we have a bone. I'm using blue for bone here. So there we have a bone. And this bone then is the malleus. And this bone is one of three what are called ossicles. And the ossicles then are the tiny bones of the middle ear. So the ossicles are then First, the malleus, the hammer, then the incus, that's a C, that is to say the anvil. So you can imagine in a blacksmith shop, somebody would have a hammer and they would be hitting a piece of metal, but the metal would have an anvil behind it. So you have the hammer and the anvil here, the malleus and the incus, and then we move away from blacksmithing to the last bit, the last bone, which is the stapes. And stapes translates to stirrup. So these bones articulate with each other. That is to say, they form joints. So there's the malleus. Now I'm going to draw a diagram like that. And here we have the incus. And then finally, we're going to have at the end the stapes, which really does have a little thing like the end of a stirrup on it. So then that is the stapes. So why do we have these things? What are they doing there anyway? What they do for us is they amplify those vibrations. Remember, there are vibrations. You had the pinna, collecting vibrations, and then the vibrations wind up here in the external auditory canal, and those vibrations are then transferred to the eardrum. And then what happens is that these little bones amplify those vibrations so that they are much more powerful by the time they get to the inner ear. So these ossicles then both transfer and amplify the energy of the sound waves from the eardrum across the middle ear and onto the oval window at the other end of the middle ear. And the middle ear is also known as the tympanic cavity. So what did I just say there? What I said is that we have another hole here. There it is, and that then is the oval window right there. So we had these vibrations from the external auditory canal onto the eardrum. The ossicles then vibrate more, and they transfer all of those vibrations onto the oval window there, which is basically a tiny hole. And we are now deep within your skull. So as you can see there, the ossicles articulate with each other. And articulate means forms joints between the bones then. And so as you see here, then you have the malleus, which articulates then with the incus, which in turn articulates with the stapes. And then the bottom of the stirrup, as I have shown there, fits over the oval window. And it moves in and out. So the stapes is there moving in and out, having transferred the vibrations all the way from the eardrum. So this creates pressure waves. On the other side of the oval window. You can think of this here like a toilet plunger. You are basically, you have these vibrations then going against this little window here, and that is creating pressure waves on the other side, just like a toilet plunger creates pressure waves inside the toilet. So then also within the tympanic cavity, that is to say within the middle ear, we have and this has, we have now a number of names for the same thing. The pharyngotympanic tube, also known as the auditory tube, sometimes also called the eustachian tube. Those are a lot of words for the same thing. So what do all these things, or rather, what does this one thing do? This tube here is one you should remember. The pharyngotympanic tube, then, this tube communicates with the nasopharynx. You remember this now, I hope. And this allows air pressure in the middle ear to be equalized with atmospheric pressure. And this allows the eardrum to vibrate freely. Okay, what did I just say? It goes like this. So here we have the eardrum. What you need to understand is that here we have the bone of your skull. And here we have the bone of your skull. And here, then, in the middle ear, this area is filled with air. So here we have air, and here we have air. But the air here and the air here have to be at the same pressure. So if atmospheric air pressure increases, that's going to bow the tympanic membrane inward, unless you wind up having it equalized here. Likewise, if atmospheric pressure decreases, then you're going to wind up having the eardrum bowing outward from the middle ear. And either way, you're going to wind up sacrificing some of those vibrations and you won't hear as clearly. So you've got to be able to equalize the air on the outside with the air on the inside. And I'm just going to do this highly diagrammatically. Remember, this is all bone here, and so what happens then is that you've got a little escape valve here. Like this. It's actually tiny. I'm way overdrawing it there. But there, then, we have the pharyngotympanic tube. There it is. That communicates with the nasopharynx, which is, of course, exposed to external air, to atmospheric pressure. So as a result, now you can wind up having the pressure equalized between those two places. So there is also then another small membrane covered opening at this end of the middle ear. And this is called the round window. And it is where the pressure waves, you remember those pressure waves created the way a toilet plunger creates pressure waves. So this then is where the pressure waves that were transferred to the inner ear finally dissipate. So what did I just say? It goes like this. We now have this one last little membrane covered opening here. Just going to do it like this. Here it is now. So that then is the round window. And what has happened in a highly diagrammatic way is that we have the pressure waves that were transferred across the middle ear are now here in the inner ear. And there is a very long tube, and I will get into that in another lecture. And that tube eventually comes along here, and these pressure waves have come all the way around. Here they are, and they make this little membrane covered hole vibrate in and out. And what that does is that it dissipates the signal, because you want to have a clear signal here. You want to be picking up new information here. And the only way that you can do that is by dampening out, basically getting rid of the old pressure waves. So they dissipate by just pushing against this little membrane covered opening here. So you have air here, and that then, as I said, is just where the round window's membrane vibrates in and out, and the pressure waves that were created die out so that new pressure waves can be created, and those can be picked up as hearing. And how that hearing is done is the subject of another lecture.